Okay, so let's have a look. We've got basic atomic structure. At its very, very basic level, an atom contains a nucleus that is at the center of the atom, and it's got negative electrons orbiting the nucleus. They're outside of the nucleus. In relative terms, a nucleus, if the whole atom is a football pitch, the nucleus would be about the size of a pea, like a garden pea on the center circle. So the nucleus is really, really small. To get more marks, you need to go into more detail, and you need to talk about the subatomic particles, and what they basically mean by that is the things that make up an atom. So in a nucleus we have positive protons and neutral neutrons, and the number of positive protons and neutral neutrons added together gives us the mass number. So the mass number is everything that we've got in the nucleus, everything with mass. The number underneath, in this case lithium, we've got a mass number of 7, so 7 things in the nucleus. We've got an atomic number of 3. Now the atomic number is also known as the proton number, and the number of protons is also equal to the number of electrons. So if we take these 3 positive protons and put them up there, we need 3 positive protons plus 4 neutral neutrons would equal the 7 for the mass number. The other thing, as I say, to remember is that whatever this proton number is, the atomic number 3, it's also going to be the number of negative electrons, and that is because atoms are neutral overall. And when you get asked that question, and you will be asked the question, you just say they have equal numbers of positive protons and negative electrons. When we move on, and in more detail now, so we've moved away from the nucleus, we've sorted the nucleus out, and we're going to look at electron configuration. Now the marks you get here are for basically using this thing called the 288 rule. Now the 288 rule is the idea that you put electrons into shells or energy levels, and they've got to go in a specific order. We've changed to carbon now, so we've got an atomic number of 6, so that means we've got 6 protons. We must also have 6 electrons, because the positive protons and negative electrons are always equal. We've also got a mass number of 12, so if we've got 6 positive protons, we must have 6 neutral neutrons to make that mass number of 12. Now when you use the 288 rule to put electrons into orbit, into their shells, basically you need to fill up the first shell first, and the first shell can only contain 2 electrons. Then you go into the second shell, and the second shell can contain 8, and the third shell can also contain 8. So if we've got 6 to put in, we put 2 in the first, so 2 electrons in the first, and then that's full. And then we need to put in another 1, 2, 3, 4 electrons to make 6. So the electron configuration for carbon here would be 2, 4, 2 in the first, 4 in the second. The other thing to remember with electron configuration is that the group number, so in this case for carbon, the group number 4 is the number of outer electrons, 1, 2, 3, 4. It is also in period 2. This is period 2. This isn't period 1, this is period 2. Period 1 starts up here. This is period 2, and if we're in period 2, it means it's got 1, 2 shells or energy levels. One final sort of thing that we can look at are isotopes, and isotopes are basically atoms of the same element but with different numbers of neutrons. The easiest way you can answer any question about isotopes is to draw tables like I've done here. So you might get asked about carbon 12 and carbon 14 and how they differ in terms of their subatomic particles. There's no need to worry. All you need to do is look at the proton number or the atomic number. It's 6, so they will both have 6 protons and 6 electrons, so 6 positive protons cancelled out by the 6 negative electrons. The same electron configuration, as you can see. The only difference is they've got different numbers of neutrons, so 6 protons and 6 neutrons make 12 for carbon 12, and 6 protons but 8 neutrons here make carbon 14. One of the questions they may ask you is about the chemistry, and when they talk about the chemistry, they're talking about reactivity and what reactions they get on with, and basically reactivity is identical. Why? Because they've got the same electron configuration, and that's all you need to put. For a higher tier paper, you might get asked about calculating the relative atomic mass, or why the relative atomic mass of an element is not always an integer, it's not always a whole number. They only really use I think copper and chlorine at GCSE, so there is a little definition that you can trot out. The relative atomic mass is the weighted average mean of all the isotopes of an element relative to carbon-12. There's loads and loads of different definitions, don't get hung up. So basically what we're saying is, if you've got here chlorine 35 and chlorine 37, the relative atomic mass is not 36, it's not the average of 35 and 37, because we've got 75% of the sample is carbon 35 and only 25 is carbon 37. So what you'd need to do is do this sort of calculation at the top: 75 times 35, so 75% is 35 and 25% is 37, and we divide by 100, and that will give us 35.5. But really, you're just talking about sort of, it's not fair to say it's chlorine 36, it's actually chlorine 35.5. Why? Because we've got more chlorine 35 in the sample. Okay, so finally, what you need to remember is that if you're going to talk about atomic structure, you can help yourself a lot with diagrams, so use diagrams a lot. So that means a labeled picture, so you can draw out the nucleus, label it up, draw the electron shells, label them, label the positive protons and the neutral neutrons. If you're going to get asked about isotopes, draw a table. Okay, it doesn't look particularly good on this, but you draw a table for each thing with the number of positive protons, neutral neutrons and negative electrons. So draw a table. A table will get you all of the marks that are available for that question. Good luck.